with these three videos, they do kind of stand alone sufficiently, I think. That I do feel that I certainly will have to follow them up. I talk about trying to bring back this hypothesis of gravitational absorption, at least for an analysis which would tie some older ideas about gravitational absorption in with certain ideas about heat and thermodynamics. And specifically, this would have to do with the lunar theory and the orbit of the moon, as taking into account lunar eclipses, and beyond that I don't go very much farther. So that's kind of all I'm interested in with these videos, and well, you'll see. I hope that's clear in the three videos to follow. But I do plan on following them up with some more comments. Especially, I'm going to need to make some comments on the equivalence principle. Anyone acquainted with physics will understand why that's important to this discussion. That's just the idea that a body's gravitational mass is the same as its inertial mass, that the two are equivalent, and that's an essential part of any discussion which will involve the hypothesis of gravitational absorption. That has to be addressed, and I'll say what I have to say about it in another video, hopefully to follow soon hereafter. And I also will probably have to say more about this idea of connecting heat and thermodynamics with gravitational absorption, because in the three short videos which follow immediately after this introduction, I can only say so much, and I'm afraid it's probably a bit too vague, but it's a start, and I gotta start somewhere. So thank you for checking these out. I hope you enjoy them. See what you think, and all right. This is a short video, kind of a proposal for a research project, I suppose. Mainly it's an inquiry into gravity, or more specifically the hypothesis of gravitational absorption, whether there's any version of that hypothesis that can be put forth in a new way, so that the general hypothesis can be revisited, done so in a falsifiable way, like I said, in a new way. I've been interested in this matter for a few years now. I'm just a philosophy enthusiast. I have a bachelor's degree in philosophy. I still think this is a pretty interesting subject. I was interested in the philosophy of science when I was a college student, and it has always, ever since then, it's always been a question that I've been interested in. So I guess I'll try to start at the beginning. One of the important parts of my education was an intro astronomy course, my first semester in college. At the end of the course, one of the last weeks of the course, the professor taught us all about galactic rotation patterns. And as he seemed to want us to take away from the lesson, he seemed to tell us that these rotations are a serious challenge to our traditional understanding of gravity. And it might even be safe to say that modern physics is not taking this challenge seriously enough. Instead, they accept the hypothesis of dark matter. Well, that seemed to be the teacher's stance, and I was very interested by that. I went on to study philosophy, like I said, but the history of science is a topic which comes up in philosophy quite a bit, and the Copernican revolution especially, because it is a paradigm, if I can say that. It was a paradigm shift in itself, but it is also the paradigm of paradigm shifts. And many a time will a philosopher refer to the Copernican revolution. Anytime he or she might be referring to changing your thinking, or completely making a 180 on the stance taken on a certain topic or something. Anyway, it appears that we might need some kind of revolution like that in physics today, with changing our theory of gravity and moving on to a newer theory. As my professor in college reminded us, or encouraged us rather, this is something that we younger people can consider, because oftentimes it's a younger mind, that a younger generation that works on these kinds of problems. Anyway, I myself was led to the hypothesis of gravitational absorption or screening just kind of intuitively. If I had learned anything about it from my couple of astronomy courses, it was just in passing, as a kind of historical hypothesis that was not very successful at all. And so I came to it kind of intuitively, because I was thinking, well, if there's anything wrong with the theory of gravity, what could it be? And that was the first thing that came to mind. Why is it that gravity meets no inhibition in matter, or no resistance in matter? How could that be? How can it be invincible, so to speak? Able to operate on all matter, but not be inhibited in that operation. That seemed to me like a violation of the conservation of energy. It also seemed to put gravity on a pedestal over ordinary light, which also it just seemed questionable. But philosophically speaking, it just seemed strange, and that gravity could behave like that. And so I asked, well, is it possible that gravitational radiation could be like light? Could it be absorbed? Could there be shadows in it? Now, just with a little thought, if you do have some understanding of the galactic rotation patterns, the uniform velocity problem, you might wonder with me whether gravitational absorption does have any merit, because the way light is absorbed as it propagates throughout a galaxy such as ours, it will be absorbed. And if gravity were absorbed in the same way, we might approach a better explanation of why we have the galactic rotation patterns which we do. That itself might not be nearly enough for anyone to pursue this hypothesis seriously, but especially because we might think it was a type of hypothesis that was conclusively proven wrong hundreds of years ago. But actually that was enough for me to give the hypothesis some thought, and try to consider if it was the answer to the uniform velocity problem in the galaxies. And certainly if it could explain the galaxy, or if it could seem to explain it rather well, then it would seem that we would have more reason to entertain the hypothesis in other applications. And that certainly becomes very difficult, as you would expect. It's no surprise, but it does require going back to some of the history of science, and that's what I would like to do right now.